Welcome to Metrology lecture series. In the present video, we will discuss the slip gauges. Slip gauges, also known as the gauge blocks, and these are the precision measuring tools used to get very accurate measurements. Slip gauges are called as the end standards because their length is measured between their flat and parallel ends. Slip gauges are the rectangular blocks made of high quality steel. They are manufactured with very high accuracy and very small tolerances. To make them strong and long lasting, the blocks are hardened throughout so they can be resist the wear during their use. After the hardening process, they are heated and cooled in the several stages. This process removes the internal stresses producing during hardening and improve their stability. Then the measuring phases are finished by process is called as the lapping process. So it is the very important. So remember this finishing process for the slip gauges. Lapping gives the very smooth surface finish, perfect flatness and the high accuracy. For the proper use, two measuring faces of a slip gauge are made perfectly flat and exactly parallel to each other. Slip gauges are also made from the tungsten carbide, which is extremely hard and highly wear resistant compared to the steel. Next we have to look for the cross section of the slip gauges. In general, cross section of the slip gauges are having the 9 mm width and 30 mm height for the gauge blocks up to the 10 mm length. Moreover, slip gauges width is the 9 mm and height is the 35 mm for gauge blocks for the more than the 10 mm length. The size of the each gauge block is permanently marked on one of its faces for the easy identification. Next we have to discuss about the ringing of slip gauges. Accurate measurement using slip gauges depends on a process is called as the ringing. Ringing means joining two slip gauges together by using a slide to sliding and twisting motion by the hand. When they are clean and smooth, they stick together firmly. The gap between the two properly rung slip gauges is extremely small, about the 0.00635 microns, but this gap is so tiny that it can be considered as the negligible in precision measurement. Because of ringing, different gauge blocks can be combined to obtain an exact required dimension. Next we will discuss the procedure for the ringing process. First we have to clean the slip gauges. Before using, clean both slip gauges with a lint-free cloth or chamois leather or a cleaning tissue to remove the dust and the oil. Next we have to slide with light pressure. Place one slip gauge on the other and move it slightly back and forward while applying the gentle pressure. So next we have to rotate to align. Then place one gauge at 90 degrees to each other and apply light pressure and slowly rotate it until both blocks come into a straight line and stick together. When the two slip gauges are rung together, the air between their measuring faces is pushed out. Because of this, two blocks stick together firmly. The sticking happens due to the molecular attraction between the smooth surfaces and atmospheric pressure pressing the blocks together. When gauges are joined in this way, the total length becomes exactly equal to the sum of their individual sizes. After ringing, the combined gauges behave like one single solid block and they can be handled as one unit without using any clamp. Next we will discuss the Indian standard on slip gauges. According to the IS 2984-1966, the size of a slip gauge is defined as the distance between its two flat measuring faces. When measuring, one face of the slip gauge is run to a flat auxiliary surface and the length is taken up to the other exposed measuring face. Slip gauges are generally made from the high grade steel and their coefficient of thermal expansion is the 11.5 plus or minus 1.5 into 10 to the power minus 6 per degree centigrade. This value is applicable in the temperature range of the 1 degree Celsius to 30 degree Celsius. Moreover, to make them wear resistance, slip gauges are hardened to a hardness of more than 800 HV. The standard IS 2984 gives the recommendation for the manufacturing slip gauges up to the 90 mm length in 5 different grades of accuracy depend on their precision level. Next we will discuss the different types of the grades. So first one is the grade 2. So this also we are calling as the workshop grade. So this grade 2 is used for the rough checks in the workshops, and this grade is suitable when production tolerances are very large. Moreover, so this is the useful for the preliminary setting of the components, position of the milling cutters, checking the mechanical width. Next grade is the grade 1. So this also we are calling as the tool room grade. And grade 1 is used for the more precise work. And applications of the grade 1 is the setting up sign bars, checking the gap gauges, setting the dial test indicators to the 0. So next grade is the grade 0. So this also we are calling as the inspection grade. So this grade 0 is used in tool rooms and inspection departments. Moreover, this grade 0 is suitable for the high accuracy work. And next one is the grade 00. This also we are calling as the reference grade. So this grade 00 kept in the standard room and it is used for the very high precision work, and it is used to check or calibrate the grade 1 and grade 2 slip gauges. So this is the very important. So grade 00 is used for the calibration of the grade 1 and grade 2 slip gauges. And another grade also there, that is the calibration grade. So this is the special grade used for the only for calibration purpose. The actual measured size of each block is given in a calibration chart supplied with the set. The chart must be referred to while building up a required dimensions. Next we will discuss the different sets of the slip gauges using in the general purpose. So there are the two sets of slip gauges are used in the general purpose. First one is the normal set, that is the M45. So in the M45, so there are the total number of slip gauges are the 45 pieces. So here M45, 45 is indicating the number of slip gauges. So in the normal set, M45 set, number of slip gauges are the 45 number of slip gauges. So next we have to look for the another set, that is the special set. So that is M87. In the M87 set, there are the 87 pieces of slip gauges are there. So in M87, 87 indicate the 87 number of the slip gauges. So I have to look for the different ranges in the M87 slip gauges. So first one is the 1.0012 to 1.009. So step is the 0.001 and total number of pieces are the 9. And next range is the 1.012 to 1.49 and step is the 0.01 and number of pieces are the 49. And next ranges of the slip gauges is the 0.5 to 9.5, step is the 0.5 and number of pieces are the 19. Next another range is the 10 to 90, step is the 10 and number of pieces are the 9. Next another, so there is the only one piece, that is the 1.005 range of the slip gauge. So it is having the only one piece. So always we have to remember these ranges in the special set of the slip gauges. So there are the other sets also available in metric units, that is the M112, M05, M50, M33 and M27. Obviously set M112 is number of pieces are the 112, M33 is the number of pieces are the 33. So next we have to discuss the selection of the slip gauges for required dimension. To build the required dimension using the slip gauges, we have to follow these steps. First one is the start from the last decimal place of the required size. Next we have to choose a slip gauge that matches the smallest decimal value. Next one is the subtract this value from the required dimension. And next one is the from the remaining value again select the next suitable slip gauge. Next we have to repeat this process until the total of selected slips equal to the required dimension. And moreover always we have to remember, always try to use the minimum number of slip gauges to build the required size. So this is how to discuss with the one example. Let's consider example building 29.758 mm using the slip gauges. So here required size is the 29.758. So step 1 is the always have to start with the last decimal value. Here last 3 decimal digits are the 0.008 mm. So we have to select the 1.008 mm slip gauge. So always we have to remember the M87 slip gauge set. So here last decimal is the 0.008. For suitable this value, so required slip gauge is the 1.008. So we have to select the first slip gauge is the 1.008. After that one have to subtract this value, then we will get the value is 28.75. So next step is the take the next decimal value in the 28.75. So in the 28.75, second decimal place is the 0.05, but we have to select the 1.25 value. So observe the table here. The ranges are there 1.01 to 1.49. So don't select the 1.05 because always have to select the minimum number of slip gauges. For this one I have to go for the 1.25 slip gauges available in the range of the 1.01 to 1.49. So we have to select the 1.25 slip gauge. So I have to subtract the 1.25 from the 28.75. So then we will get the value is 27.5 mm. So next we have to select the remaining whole number slips. So now we have to make the 27.5 mm slip gauges. For this one I have to select the 7.5 mm and 20 mm slip gauges, because so another ranges are there, 0.5 to 9.5. So in this range 7.5 mm slip gauge is available. So we have to directly use the 7.5 mm, and 10 to 90 mm range of the slip gauges, 20 mm slip gauge also available. So we have to select the third slip gauge is the 7.5 and fourth slip gauge is the 20 mm slip gauge. So here total number of the slip gauges are the 4 number of slip gauges, that is the 1.008, 1.25, 7.5 and the 20. So now we have the 20 one slip gauge, 7.5 another slip gauge, 1.25 one slip gauge and 1.008 another slip gauge. So summation of these values we are getting the 29.758 mm. So the above 4 slip gauges are required to build the 29.758. Next we have to look for the competitive exam oriented multiple choice questions on the slip gauges topic. So these type of the questions are asked for the various kind of the competitive exams like the staff selection and APPSC and the RRB exams. So first question is the slip gauges are used to measure option A surface roughness, option B linear dimensions very accurately, third one angle directly, fourth one hardness. So we know that one the slip gauges are used to measure the linear dimensions and very accurately. Second question is the slip gauges are made of option A mild steel, option B high carbon alloy steel or tungsten carbide or ceramic, option C cast iron, option D aluminum. So already we have discussed. So slip gauges are made of the high carbon alloy steel or tungsten carbide or the ceramic. So option B is the correct. Next we have to look for the another question. The process of sliding two slip gauges together so that they stick due to the molecular attraction is called as the option A lapping, option B ringing, option C honing, option D scraping. So we know that one this is the ringing process, so option B is the correct. Next question. In an M87 standard slip gauge set, the total number of pieces is option A 49, option B 56, option C 87, option D 103. We are already discussed. 87 indicate the total number of pieces of the slip gauges, so option C is the correct. Next question is the ringing phenomena occurs due to the magnetism, option A, option B atmospheric pressure only, option C molecular attraction and thin oil film, and option D gravity. So we know that one. So this is the due to the molecular attraction and the thin oil film. So option C is the correct. Next question is the slip gauges are mainly used for option A production work, option B checking flatness, option C calibration of measuring instrument, option D cutting metals. So we know that one the slip gauges are mainly used for calibration of measuring instrument, so option C is the correct. Next question is the least count of a standard slip gauge set M87 is. So option A 0.1 mm, option B 0.01 mm, option C 0.001 mm, option D 1 mm. So already we remembered the table. So in the special set slip gauges, so the minimum least count of the slip gauge set is the 0.001 mm. So option C is the correct. Next question is the if two slip gauges of 1.25 mm and 1.008 mm are run together the total size is. So total size of the slip gauge will become the 1.25 mm plus 1.008 mm. So total size will become the 2.258. So option B is the correct. And next question is the minimum number of slip gauges should be selected because option A, it reduces the cost. Option B, it reduces the cumulative error. Option C, it saves time only. Option D, it increases friction. So correct option is the B. So it will be reduce the cumulative error. Next question is slip gauges also called option A, feeler gauges. Option B, gauge blocks. Option C, plug gauges. Option D, snap gauges. So we know that when the slip gauges are also calling as the gauge blocks. So option B is the correct. Next question. The accuracy grade used for calibration in the laboratories is option A, grade 2. Option B, grade 1. Option C, grade 0. Option D, grade 00. Just now we discussed grade 00 is used for the calibration in the laboratories. So next question is the which of the following is not an error source in a slip gauge use? Option A, temperature variation. Option B, dirt between the blocks. Option C, ringing film thickness. Option D, magnetic field of the earth. So option A, B, C are the sources of the error while using the slip gauges, but option D is the not a source of the error in the slip gauge uses. So option D is the correct. So this is the discussion on the slip gauges, and thank you.